In this lesson, we are going to be working on the power to a power rule, and we're going to be able to apply this rule to our exponents in our algebraic expressions, as well as making sure that we are applying the product of powers as well as the quotient of powers at the same time. Remember, our exponent rules so far are the product of a power rule, and that is where we have the same base and we are multiplying them together. Then we can add the exponents. And our quotient rule is that when we have the same base that we are dividing, we can subtract the exponents. Alright, let's take a look at our next examples. So, if we have 2 to the third power, and that's being raised to the second power, that means I have 2 sets of this expression, which is 2 to the third. So I have 2 to the third power, which means 2 times 2 times 2. And the square means I have 2 sets of those being multiplied together. So if I write that out as repeated multiplication, I now would have, keeping the base, putting them all together, I would have 6 2's, or 2 to the sixth power. In this example, I have 2 to the fourth power, and that's being raised to the third power. That means I'm taking 2 times itself 4 times, and I'm going to do 3 of those groupings. This is what it would look like in expanded form and as repeated multiplication. Now I'm going to simplify, so I will keep my base, which is 2, and I will put all the exponents, all of those 2 together to create my exponent, and there are 12 2's. So, is there a way that we can use the exponents 3 and 2 to come up with our final exponent of 6? Is there a way that I can use these 2 exponents when I have a power raised to another power to come up with my final exponent? Yes, there is. And what we can do is when we have a power raised to another power, we can multiply the exponents together to come up with our final exponent in our expression. This is a power to a power. Let's take a look at the next example. So I have 3x raised to the second power. When I write this out as repeated multiplication in expanded form, that tells me that I have 2 groups of 3x. What I could do then is write this with my exponents. So I would have 3 to the second power and x to the second power, or that would give me 9x squared. So when I have a power raised to a power and it is an expression, I want to make sure that I'm giving each of the pieces of my expression to the second power. When I have 3 to the second power x to the third, and I'm going to expand that, I'm going to have 3 to the second power, which is 2 3's, and then I'm going to have x to the third power, which means there are 3 x's. This exponent of a 3 tells me that I need 3 of these groupings. So I have 3 times 3 and 3 x's, and 3 times 3 and 3 x's. When I simplify, I'm going to keep the base of 3, and there are 6 3's, so that will be 3 to the sixth power. And then I have my base of x, and there are 9 x's, so that will be x to the ninth power. So notice I would be multiplying 2 times 3, power to a power, 2 times 3 to get my power of 6 for my 3, and 3 times 3 to get my power for my exponent. of my base of x. That's to the 9th power. All right, let's take a look at this example. I have 2y squared and over w squared. So I'm going to do this expression 2y over w, and the exponent of a 2 tells me I have to write 2 of these. So I've written this out as repeated multiplication, and now I'm going to simplify. 2 is my first base, or the coefficient, and I'm going to have 2 2's. And then I have my base of y, and I have 2 y's. And then I have my base of w in the denominator, and I have 2 of those. So that's going to be 2 squared, y squared, and w squared. If you take a look, each of these is to the power of 1. And in our last example, we discovered that if we multiply the exponent on the outside of the parenthesis times the exponent on the inside, that will be our result. Let's take a look at our next example. So we have 2 to the third, y to the third, x to the second. So if I write that out as repeated multiplication, that tells me I have 3 2's, 3 y's, and in the denominator I have 2 x's. The exponent of a 3 on the outside of the parentheses tells me that I want 3 of those groups. Now we're going to simplify. In the numerator, I have the first base of a 2. I have 3, 6, 9 2's all together, so that's going to be 2 to the 9th power. Then I have my base of y. I have 3, 6, 9 y's all together. And in the denominator, I have a base of an x, and I have 2, 4, 6 x's all together. That would be my simplified expression. So what would be a shortcut? I could take the exponent on the outside and multiply it times the exponent on the inside, and that would give me my new exponents, and that would be a shortcut instead of writing out the repeated multiplication. So for our power to a power rules that we want to use, what we can say is that if we have a base that has an exponent and it's raised to another exponent called a power to a power, I simply can multiply those two together to get my new exponent. If I have two bases that are being multiplied together in the same expression and they are being raised to another power, I can simply keep the base of the first base and multiply the two exponents together, and then I have my second base and I can multiply the two exponents together. If I have a quotient, meaning I have two different bases that are being divided, and that quotient is being raised to a power, I can bring that power inside to the numerator, keep the base, and multiply the exponents together, and I can keep the base in the denominator and multiply the exponents together. It seems similar to the distributive property, where I'm distributing the exponents. Let's take a look at these examples. So I have f to the fourth to the third power. If I were to write that out as repeated multiplication, I would have 4 f's, And then I would need 3 of those groups that I would need to put together. When I simplify, I keep my base and I see how many F's that I have, which is 12. Now the shortcut would be to keep the base and to multiply the exponents together, which would be F to the 12th. Let's try this example by doing the shortcut. In the numerator, my base is an H, and I simply multiply the exponents together. 6 times 5 would be 30. In the denominator, my base is a K, and I will multiply the exponents together, and I would have 10 K's, which would be K to the 10th. Let's take a look at another example. I have 7C to the 3rd power. If we were to write this out as repeated multiplication, I would have 2 groups of 7 that have a 7 with 3 C's, and I would have 2 of those. My final expression would be to keep the base of 7 and add the count how many I have, which would be 2 of them. And then my C's, I would have 6 of them. If I wanted to take my shortcut, I would multiply 1 times 2, power to a power would be 7 squared, and then I would multiply 3 times 2, so I would have C to the 6th power. And then I can finish simplifying by taking 7 squared, which is 49, C to the 6th power. Let's take a look at letter D and see if we can do that with the shortcut. My first base in the numerator is K, and if I multiply the exponents together, 6 times 5 would be 30. The next base I have in the numerator is M, and if I multiply the exponents together, 3 times 5 would be 15. In the denominator, I have my base of N, and if I multiply the exponents together, 4 times 5 would be 20. In our next example, I have 3m to the 2nd power raised to the 4th power, and I have 2m to the 5th raised to the 2nd power. Now I can write this out in expanded form, or I can take the shortcut, remembering that this is 3 to the 1st power and 2 to the 1st power. Let's show what it would look like in expanded form. So 3m to the 2nd power would be a 3 with 2 m's, and that entire grouping is raised to the 4th power, which means I want 4 of these. In our next expression, I have 2m to the 5th raised to the 2nd. So I have a 2 with 5 m's, and my exponent of a 2 tells me I need to have 2 of these groupings. So to simplify, I have 1, 2, 3, 4 3's, which gives me 3 to the 4th power. I keep my base of m, and I have 1, 2, 3, 4. I have 4 groups of 2, so that's 8. And then I have 5 more, would be 13, and 5 more would be 18. And then I have 2 2's, which would be 2 to the 2nd power. So when I simplify this, I have 3 to the 4th power. 3 times 3 is 9, times 3 is 27, times 3 is 81. And I have m to the 18th power, and then I have 2 to the 2nd power, which is 4. And then I want to make sure that I multiply what I can together. So I would have 81 times 4, which is 324 m to the 18th power. Now our shortcut, I'm going to show you up here, would be this. Let's take our exponents and we're going to multiply them together. So I'm going to have base of a 3 to the 4th power. And I'm going to multiply these two together. I'd have m to the 8th. Then I'd have my base of a 2 to the 2nd power. And I'd have my m's. 5 times 2 would be 10. So to simplify, 3 to the 4th power, 81. 2 to the 2nd power is 4. And I'd keep my base and add the 8 and the 10 together, which would be 18. And then I could simplify to 324 m to the 18th power. So with our power to a power rule, remember what we're doing is we are keeping the base and we are multiplying the exponents together. So if I have an example like 3x to the 4th power and I'm raising it to the 2nd power, we're going to keep the base and we're going to multiply the exponents. Keep the base and multiply the exponents. And then we can finish simplifying if it is a number to a power. Remember, you're distributing that power to everyone, to each part of the expression. Please remember to complete the reflection.